Circle theorem, theorem 1. Equal chords of a circle subtend equal angles at the center. So we are given that two chords are equal in a circle. First of all, chord is nothing but a line segment where the end points of the line segment will be touching the circumference of the circle. So such type of a line segment which is drawn inside the circle is called as a chord. Okay, we are given two chords which are equal. They are going to make angle with the center of the circle. That is, AB is a chord which is going to make an angle with the center. Same way, CD is a chord. This is going to make an angle with the center of the circle. We are going to prove that angle AOB and angle COD, that is the angles made by these two chords with the center, are equal. Okay, so let us prove that. The proof of this theorem is going to be very simple. Let us prove first. So, for the proof, okay, whenever we are going to talk about the theorems relating to circles, we will be always proving mostly based on the congruency conditions. So, first of all, this angle AOB, we are having it in the triangle AOB. Same way, angle COD, we are having it in the triangle COD. So, angle AOB and angle COD should be equal, for which we are going to consider the two triangles AOB and COD. So, in triangle AOB and triangle COD. Okay, we are going to prove it based on the congruency conditions. So, OA and OD. Can you see? What is OA and OD? That's nothing but the line joining the center and the circumference. So, they are going to be the radius. So, OA equal to OD. Same way, OB and OC are radius again, because it's the line joining the center and the circumference. So, OB and OC will be equal again. So, OB equal to OC. They both are because they are the radius of the circle. Radius of the circle are always constant. Then we are given AB and CD are equal because they are equal chords. It is mentioned in the question. So, AB equal to CD because they are equal chords. So, now we are having three sides of a triangle equal to the three sides of the next triangle. So, therefore, the two triangles angle AOB and triangle COD are congruent. If it is so, okay, then any part of this triangle can be equated with the corresponding part of the next triangle. So, therefore, we can say angle AOB, this angle, whatever we require, that angle is equal to angle COD. This is by CPCT, that is corresponding parts of congruent triangles, and this congruency is by SSS congruency condition. Right? So, the two angles are equal. What are the angles actually? Angle AOB is the angle made by the chord AB. COD is the angle made by the chord CD. So, the two angles are equal, which means equal chords of a circle subtend equal angles at the center. That's it. Okay? This will be the converse part of the theorem. If the angles subtended by the chords of a circle at the center are equal, then the chords are equal. So, what are they saying here? If suppose we are having a circle, okay, for example, consider this circle, okay, we are having two chords and we have a center for the circle. If this chord is making an angle with the center, okay, and if this chord is again making an angle with the center, if these two angles are equal in measure, then the two chords must be equal. That's it. So, this is going to be the converse part of the theorem which we had discussed. The converse part is also true. That's it. Thank you.